Hello, in this video we're going to walk through one of the examples from the textbook, specifically number 10.10 from page 193. And I'm hoping that this will help us get you know, a nice grasp of the introductions here to hypothesis testing. So there's two major parts to this that I want to focus on. Number one is the terminology and extracting the key facts out of the word problems. But then the other part is also the key steps in the calculation and the decision making. So in this problem, I'm going to read it to you briefly here. It says, let's assume that over the years, a paper and pencil test of anxiety yields a mean score of 35 for all incoming college freshmen. We wish to determine whether the scores of a random sample of 20 new freshmen with a mean of 30 and a standard deviation of 10 can be viewed as coming from this population. Test at the 0.05 level of significance. So from that terminology, or from the language there, the first sentence is establishing the idea that the population mean from all the previous tests to freshmen was a mean of 35. So from that, we're going to extract mu, which is the symbol for the population mean being 35. They did not give us a population standard deviation, but they did give us this information about the sample. So the statisticians here conducted a survey. They sampled 20 students of the current freshman class, and that group had a mean of 30. So X bar is the sample mean of 30, and a standard deviation of 10. And then the last sentence gives us the information that we need as far as how we actually make our decision whether or not this group of 20 students represents a new freshman class. And the question is the mean of this whole freshman class significantly different than the mean of the previous population of 35? So our sample most likely is going to have a sample mean different than 35. It would be a little odd if we selected 20 students out of the entire freshman class and the mean was exactly 35 as in previous years. But so we can expect it to be different. But the question is just how different does it need to be for us to say that there is a statistically significant difference? This level of significance is going to be giving us the information we need to make that decision. Many times you'll see the lowercase alpha being the symbol representing what that level of significance is. So I'm writing it here as alpha is 0.05. Now we're going to walk through the process that the textbook uses on page 187 in gray there in that box, and I think it's a great way to just follow the step-by-steps, and it's something we can use from here on out throughout the course. And this is called a hypothesis test. We're conducting a z-test for a population mean. And the first thing we need to do is kind of identify the research problem itself. And the fundamental question of this problem is, does the mean of the test scores of all freshmen, the current freshmen, differ from the population established from before? So our statistical hypothesis is this. The null hypothesis is what's always going to be referred to as basically the previous bit of information or the population mean that we had previously. So the null hypothesis is mu is equal to 35. Then our alternative hypothesis is usually established by what the research question is. And since our research question is, does the mean of the test scores of all current freshmen differ from the population, then we're going to establish an alternative hypothesis, with capital H and a lowercase 1 there, H sub 1, is going to be that mu is going to be not equal to 35. Again, our null hypothesis, coming from the previous year's population mean, is that mu is equal to 35. And our alternative hypothesis, which comes from the research question, is that the mean is not equal to 35. Our decision rule is based off of our level of significance. So since our level of significance was 0.05, then we're going to reject the null hypothesis if our z-score is either greater than 1.96 or less than negative 1.96. And let's just review where this comes from. If our level of significance is 0.05, that means that we need to find the location on the normal curve such that that rare event is going to happen 0.025 times either, pardon me, let me back up a little bit there. We're establishing the rare event, which is going to say that it is so rare that we're going to reject the null, such that the area under at a spot where the area under the curve is 0.025 up in this tail, or the area in this tail 0.025 as well. And this is found by taking the level of significance and dividing it by 2. So this 5% chance, or 0.05, has to be split up into 2 different equal parts, one in one tail and one in the other. And this is due to the fact that our alternative hypothesis is establishing that we're saying that the mean is not equal to 35. It's not establishing or wondering if it's greater than or less than. It's open to the possibility of either or. So we have to split that 0.05 into 2 different tails, or what later on we'll call a two-tailed test. So in the normal curve, the location such that 95% is centered about the mean and 0.025 above and 0.025 below a certain mark is a z-score of either positive 1.96 or negative 1.96. That again is established by this level of significance. Now there's 2 major calculations we have to conduct here. The first calculation is we need to find our standard error. So the standard error, if you recall, is the standard deviation divided by the square root of the sample size. Since we don't have a population standard deviation, we're going to use the standard deviation they gave us from the sample. So we're going to plug that in here. And the sample size, if you recall, was 20. So that goes in the denominator. So 10 divided by the square root of 20 gives us a standard error of 2.24. Next calculation we need is to actually find the z-score to compare to this 1.96 or negative 1.96. So this is the z-score from our sample. And to find that, we take the sample mean, subtract from it the population mean, and divide by the standard error. Or in this case here, we had a sample of 30, or sample mean of 30, minus the 35, which was the population mean. And we divided it by the 2.24, which was our standard error here. This is the key thing we need to not forget. And that gives us a z-score of negative 2.23. So that negative 2.23, when we take a look at it and plot it on this graph, is going to be out here beyond negative 1.96 or further out in this tail. So we're saying that this is such, if this was, let me back up, this falls into that rare instance so that we are actually going to then reject the null hypothesis. We're not going to be comfortable saying, well, we just think it's a high sample. We're going to say that we actually think it's a sample from a population that has a mean significantly different than 35. So our decision, again here, is to reject the null hypothesis at the 0.05 level significance because our z-score from the sample of negative 2.33 is less than the one established by our alpha of negative 1.96. And how to interpret that is this. The mean test scores for all freshmen, current freshmen, does not equal the previously established average. Hope that helps walking you through that process.